We've all experienced it, swallowing a small, chalky tablet, waiting 20 minutes, and watching an ailment simply vanish. Yet this inert object has no way to see or steer. It must navigate an incredibly chaotic biological network to find a highly specific destination. Pharmacological classification provides the scientific framework that makes this navigation possible. This taxonomic system categorizes every drug we take based strictly on its physiological target and its specific mechanism of action, the exact way it behaves once it arrives. Following this map reveals a clear path of medical complexity, starting with localized chemical reactions in the gut and scaling up to the profound biological alterations within the human brain. The human stomach serves as the most basic biological battleground for drug intervention. Antacids occupy the absolute baseline of our pharmacological classification system. These drugs function without the need for complex cellular receptors or intricate biological pathways. This diagram shows exactly how they operate. Basic molecules enter the stomach and trigger a brute force acid-base chemical reaction, neutralizing the pH. This direct chemical reaction brings relief into a calm, neutral state, isolated strictly to the boundaries of the stomach lining. Antacids represent pharmacology at its most primitive, a blunt chemical neutralization requiring zero systemic navigation. To move up the classification ladder, we leave the isolated stomach and enter the vast interconnected highway of the cardiovascular system. Antihistamines represent the next tier, moving the intervention from localized chemistry to body-wide targeting. The challenge increases here. Antihistamines must actively ride the bloodstream to hunt down specific targets spread throughout various tissues. This diagram illustrates the mechanism. Antihistamines identify and physically bind to precise histamine receptors, occupying the space to deflect incoming allergy-triggering signals. By operating this way, antihistamines elevate drug classification to a highly precise systemic targeting mechanism. The human brain represents the ultimate, most heavily fortified biological fortress. Neurologically active drugs sit at the absolute pinnacle of the pharmacological classification list. These agents must overcome a massive biological hurdle, penetrating the blood-brain barrier, a highly selective membrane that protects our central nervous system from outside chemicals. Once inside the central nervous system, we encounter specific subclasses, starting with tranquilizers. Tranquilizers depress overall central nervous system activity. By lowering the rate of neural firing, they alter mood, reduce anxiety, and release physical tension. A second distinct neurological subclass operates quite differently: analgesics. This split-screen chart compares the two mechanisms. On the left, tranquilizers lower the overall neural firing rate. On the right, analgesics intercept specific pathways, severing a pain signal before it reaches the brain's processing center. These agents represent the frontier of pharmacology, drugs engineered to directly manipulate human perception and state of mind. Zooming out from the microscopic pathways of the brain allows us to see the entire holistic system of the human body. This classification system functions as an escalating mirror of our own biological complexity. Every time you take a pill for heartburn, an allergy, or a severe headache, you are actively engaging with this highly categorized targeting system. Understanding this hierarchy demystifies medicine. It frames every pill as a precise, targeted biological tool.